Good morning children, welcome to digital lessons. Today we are going to discuss about acids, bases and salts. Children, do you know what are acids? Yes, by thinking the name acid itself, you will get some acids in our kitchen. What are the acids present in our kitchen rooms? Generally, you will get lime water and tamarind. Yes, these are the excellent examples for acids. Now, can you list out some bases which are present at our home? Yes, NaOH solution, yes, lime water. These two are the excellent examples for bases. Now, today we will see how these acids are in taste and in chemical reactions. Now, we will go for the chemical reactions of acids and bases. Now, let us start. Acids are generally sour in taste. Whenever we take a litmus paper and dip it in acids, the blue litmus turns to red. Now, you see in this picture a blue litmus is turned to red. Bases are bitter in taste and they are common characteristic of bases. Now, when bases are dipped in with red litmus paper, they will turn red litmus to blue. Just observe the picture here. Now, in this picture a red litmus paper is turned to blue. Now, children, we will see some simulations for the chemical reactions of acids and bases with these indicators. Now, what are the indicators generally we use? Now, only we used, we have seen the demonstration for red litmus and blue litmus. Along with it, we also use methyl orange and phenolphthalein indicator in our laboratory. Now, just look at these simulations now. Just observe here, there is a methyl orange and there is a droplet of an acid. To this droplet of acid, whenever we add this methyl orange indicator, now let us see what happens now. Now, the acid turn to red in color. Now, it is the property of acids with methyl orange solution. Next, when we add phenolphthalein indicator, now see droplet is colorless, that means there is no action of phenolphthalein on acids. Next, whenever we dip this droplet with blue litmus paper, now see blue litmus turn to red, this means acids turn blue litmus to red. Next, we will dip red litmus paper. Now, you see there is no change in the color of red litmus, it is the characteristic of acids with all our 4 indicators, that is methyl orange, phenolphthalein, blue litmus and red litmus paper. Now, we will see the same taste with for bases also. Now, you see here is a droplet of base. Now, when we add methyl orange indicator, just observe it is turned to yellow, it is the characteristic of bases with methyl orange solution. Next, phenolphthalein indicator, this droplet is turned to pink, it is the characteristic of base with phenolphthalein indicator. Next, with blue litmus, now blue litmus remain as it is, there is no change. Next, red litmus, now red litmus turn to blue, it is the characteristic property of bases with red litmus paper. Now, once again we will revise, whenever methyl orange is added to basic solution, it turn to yellow. Whenever phenolphthalein indicator is added to base, it turn to pink. Whenever blue litmus is dipped, there is no change in blue litmus. Whenever red litmus paper is added to the droplet, there is a change of color, that is blue. It is the characteristic property of bases. Now, let us see, there are some chemicals listed out in our book also: hydrochloric acid, H2SO4, nitric acid, acetic acid, sodium hydroxide, potassium hydroxide, magnesium hydroxide and ammonium hydroxide, calcium hydroxide. Out of them, some chemicals are acids, some chemicals are bases. Now, let us see what happens whenever we dip blue litmus paper in all these beakers. Just see, now slowly blue litmus changed to red, that is the characteristic property of acids. This shows that acids turn blue litmus to red. Next, we will add red litmus paper now. Just observe what happens. Now, red litmus paper turn to blue for bases. it is the characteristic property of bases. Next, there is a methyl orange solution now. Now, this methyl orange solution we are all adding into the beakers containing the solutions of acids and bases. Now, let us recall what happens when we add methyl orange solution. Slowly you change, all acids turn to red, that is the characteristic property of acids for methyl orange. Now, all bases turn to yellow, that is nothing but the color of methyl orange itself. Next, whenever we add phenolphthalein indicator to all these beakers containing the acids and basic solutions, now let us add phenolphthalein indicator now. Let us see what happens. For acids there is no change, for bases the pink color is appearing, that means it is the characteristic property of bases with phenolphthalein indicator. Now, by this we can conclude the indicators test for acids and bases. Now, children, now here there is a person suffering with acidity, that means we might have observed in our daily lives also, whenever you eat some non-veg food at night times, then next day morning you will feel acidity, there will be stomach pain in your stomach. Now, how to get relief from this stomach pain? Now, if you chew any tablets, now there will be many tablets available in market such as Eno powder and also Histac, Dizine, all these antacid tablets you will relieve from the pain of acidity. Now, what happens whenever acid formed in our stomach? Slowly whenever we take these tablets, there is a base in them that neutralizes the acid, therefore, we will get immediate relief from the acidity. Now, here we will discuss what are the chemical reactions occurring in acids and bases. Just now we have seen litmus test and phenolphthalein and methyl orange test for the indicators. The same tabular column is given in our book also. Now, you can fill this like this. Now, first acid is HCl. Now, I am doing the example for one acid and one base. Now, what happens to the HCl solution? Whenever we dip it in red litmus paper, there is no change, it will be red in color. Now, what happens to the acids? When we dip with blue litmus paper, blue litmus turns to red. What happens whenever acid is added with phenolphthalein indicator? Now, it becomes colorless, there will not be any change in color. What happens whenever methyl orange solution is added to acidic solution? Simply it turns to red. It is the characteristic test for acids. Now, we will see for one base, that is we will take the first base in the list, that is sodium hydroxide solution. Now, what happens whenever we dip a red litmus paper in sodium hydroxide, it turns to blue. Now, what happens whenever we dip blue litmus paper into sodium hydroxide, it will remain as blue, there will not be any change in its color. Next, what happens whenever we take phenolphthalein indicator, it turns to pink in bases. What happens whenever we add methyl orange solution, it will be yellow in color. Now, it is the characteristic property for acids and bases. Like this, you fill the tabular column by doing the experiments in your chemistry lab with the remaining acids and bases. Now, children, have you ever heard the term all factor indicators? Now, all factor indicators is nothing but, now these are also indicators. There are some natural indicators such as onion, cloves, and with this what we can perform? Now, simple experiment. Now, take an onion and chop it into fine pieces and cut them, and take two pieces of cloth. In one cloth you strip it with this onion pieces, and another cloth also you strip it with onions, and keep them in your refrigerator for one day, and after one day you take it out and wash them, in first one in acidic solution, second one in basic solution. Now, what happens? Now, you observe the smell. On observing the smell, you will notice that the strip which is rinsed with acidic solution, you will get the smell of onion, but the strip which is rinsed with base, it loses its color of onion, It indicates that the smell is loosen whenever we add it to a base. Now, these are nothing but all factor indicators. Now, let us see, there are some substances whose order changes in acidic or basic media. Such substances are called olfactory indicators. Now, see examples are onion, vanilla essence, normally you will use for preparation of cakes. This also you will find at your home. You can do this experiment immediately after the class. Now, with cloves also you can perform this experiment. You will get the clove smell, and vanishing of clove smell also you can see very easily. You can observe with your nose. Next, what happens you see here, all factor indicators. We are taking 3 indicators, those are onion, vanilla essence and clove oil. Now, after adding with acidic solution, the smell is retaining. After whenever you wash them with base or dip them in bases, they will lose their original smell. It is the characteristic of bases towards these indicators like onion, vanilla essence and clove oil. Therefore, such indicators you will call them as all factor indicators. Now, let us perform some experiments with acids and bases. Now, let us see first reaction of acids with metals. What happens whenever a metal is added to the acid or in vice versa to the metal, whenever we add any acidic solution, what will happen? Yes, you will get some gas evolving out. Do you know what is that gas? Now, let us see small experiment. We will see the gas evolving out here. Just observe experiment, afterwards we will do simulations for it also. Now, let us see what are the materials required for this experiment. The materials required are very easy: test tube, one delivery tube for the discharge of gas, and glass trough, candle, and this glass trough is filled with soap water solution. Why soap water is added here? Soap water you can see bubbles very easily, and dilute HCl and one metal like zinc granules here we are taking, but we can also use metals like magnesium, which is easily available in the form of Diwali crackers to you. Now, you see reaction of metals with acid. Now, in this experiment we are seeing a conical flask. In this conical flask we added HCl and some zinc granules in it. Now, you observe that there are some bubbles evolving out of it. Now, what happens? What is this gas is evolving in the form of bubbles? Now, yes, definitely it is hydrogen gas. Now, what happened in this reaction? Whenever an acid is added to metal, the metal displaces hydrogen from the acid. It is a simple displacement reaction. Now, here hydrogen gas is being evolved. Now, how do we test the presence of this hydrogen gas? Simply by lighting a matchstick before the gas which is evolving out. Now, let us see here, one matchstick we have to take and some gas is evolving out of this test tube. Now, let us see this test tube. Now, what happens? There is a matchstick. Immediately you will observe a pop sound with the matchstick. Now, this pop sound identifies that gas is hydrogen gas. It is the characteristic property of hydrogen gas. Children, now we will see small simulation for this experiment. By this you will remember the experiment very easily, and what materials we are using in this experiment also covered in this simulation. Now, let us feel that you are performing experiment on your own. Now, what is the first step in our experiment? First step is take a boiling tube. You can observe that one boiling tube is coming out. Next, add zinc granules to it. Now, zinc granules are being added into the boiling tube. Now, fix the rubber cork. A rubber cork is being fitted with 2 holes. One is for delivery tube, another one is
Diesel funnel.
Next, fix the
Diesel funnel.
Now, funnel will have an opening here. Next, arrange the delivery tube. Now, a delivery tube is coming out. Next, take a water tub and add soap water to this water tub. Now, it is filled with soap water. Now, add some zinc granules and HCl acid into the boiling tube. Now, you see some gas is coming out, it is evolving out in the form of bubbles. Observe this carefully, this is nothing but our hydrogen gas. Now, see in small simulation that you can see in your textbook in the form of a diagram like this. Now, you can see in your textbook a diagram experimental arrangement for your setup. Now, here there is a stand and boiling tube, rubber cork, delivery tube and candle, and how you are getting pop sound with hydrogen. Now, what is the experimental procedure we adopted here? Now, takes 10 ml of dilute HCl and add into the beaker which is containing or boiling tube which is containing zinc granules in it. Now, a gas is evolved out of it, that gas is nothing but hydrogen gas. It is with the small chemical reaction of zinc metal with HCl. Now, we can see the chemical equation here. Now, whenever acid is added to the metal, it displaces hydrogen out of it, that is nothing but hydrogen is evolving out here in the form of gas. Now, what happened really in our chemical reaction? Now, first we are taking zinc granules, to that we are adding HCl. 2 molecules of HCl is reacting with zinc metal and it is forming in the form of zinc chloride salt and with the evolution of hydrogen gas. Now, what happened really in this example? Now, zinc metal whenever added to the acid, it is displacing hydrogen out of it. It is a simple displacement reaction. The same we can do with the bases also, same reaction you will get. Now, let us see reaction of bases with metals. Now, what are the materials required? Same materials like test tube, delivery tube, glass trough, candle, soap, water. Instead of dilute HCl, here we will take NaOH solution. Now, same procedure, instead of dilute HCl, we add dilute NaOH solution. Experimental setup is also same. We are taking instead of HCl, we are taking dilute NaOH solution. Now, whenever this dilute NaOH solution is added to the zinc metal, now some gas is being evolved out of it, that gas is nothing but hydrogen gas. Whenever we take a burning candle, we will get a pop sound, it is the sound of pop sound. By this we can identify that gas is hydrogen. It is a very simple chemical reaction. Now, let us see what happens with the bases. Small chemical reaction here. Whenever zinc is added to NaOH, we will get the formation of sodium zincate. Now, let us see how sodium zincate is formed. Now, you see a dilute NaOH solution added to zinc, we are getting sodium zincate along with the evolution of hydrogen gas. It is a simple displacement reaction. Note down that all bases will not liberate hydrogen gas whenever added with metals. Only some bases only react with metals to liberate hydrogen gas, that you will learn in your later classes. Now, you see what happens whenever you take salt such as sodium carbonate. Have you ever heard of sodium carbonate? Yes, it is nothing but our washing soda. Do you ever heard about bicarbonates? Yes, baking soda, it is nothing but sodium bicarbonate. Like this, we will find many carbonate salts, magnesium carbonate, zinc carbonate and also calcium carbonate in the form of limestone. Now, let us see what happens to all these carbonate salts whenever they are added to acids. Now, let us see. Now, at our home we can easily find sodium carbonate in the form of washing soda. You take a 2 grams of sodium carbonate, add 10 ml of dilute HCl to it. What happens? You will get some effervescences out of it. What is meant by effervescences? You will see small bubbles are liberated one gas. What is that gas? Now, we will see what gas is generally present in carbonates. Yes, it is carbon dioxide. Now, let us see small simulation for it, afterwards one small video. We will go for simulations. Now, children, now we will have a small simulation for our experiment, that is metal carbonates reacting with acidic solution. Now, how these metal carbonates react with acidic solution? Now, here we are having a small simulation and experimental setup also. Now, let us look at it. Now, take a boiling tube. Now, add a metal carbonate to it. Best example for metal carbonate is sodium carbonate, it is washing soda. It is generally available at our homes also. Now, fix the rubber cork. You notice that rubber cork is having two holes, one is for thrust-filled funnel, another one is for delivery tube. Now, attach the thrust-filled funnel. Now, why this thrust-filled funnel is used here? In order to deliver acid into the boiling tube. Delivery tube is attached to the another hole of the rubber cork. Now, take a test tube which is containing lime water. Now, initially notice that lime water is not having any color. Now, you observe what happens carefully, add some HCl to this carbonate salt. Now, some gas is evolving out. What is this gas? Yes, it is CO2 gas, carbon dioxide. What is the test for this CO2 gas? Whenever it is added to lime water, it turns lime water into milky. Now, you can see white precipitate here. Why this white precipitate is formed? Due to the formation of calcium carbonate. It is nothing but lime. Now, children, all this we did in laboratory, but this experiment can also be done at our homes very easily. Now, what are the general acids and bases find in our homes? Now, generally we will find natural acids in our house. Therefore, now let us see small video about our natural acids and bases. Now, vinegar, it is nothing but acetic acid, it is present in our house, and another carbonate salt is baking soda, it is sodium bicarbonate. Whenever we add vinegar to this sodium bicarbonate solution, we are getting a gas out of it. It is nothing but carbon dioxide gas. Whenever we bring lime water to it, this lime water turns milky. Now, you can observe change in lime water color. It turns into white. It indicates that the gas is carbon dioxide gas. This simple experiment you can do at your homes with acetic acid and baking soda. Now, children, we have seen a simulation and experiments set up for it. Now, we will see how we will do in our labs. Just small recap of it. Now, we will arrange our experimental setup in our lab like this. Now, what happens whenever this acid is reacted with a metal carbonates and metal bicarbonates, you will get always the evolution of carbon dioxide gas out of it. Generally, whenever metal carbonates react with acids, you will get carbon dioxide gas out of it along with the formation of salt and water. Now, whenever metal hydrogen carbonate, that is nothing but bicarbonates added with an acid, you will get a salt and water along with the evolution of carbon dioxide gas. Therefore, always you remember that whenever acid is added to carbonates or bicarbonates, you will get the evolution of carbon dioxide gas along with its salt formation and water. Now, do you know what are acids and base reactions? Already we have seen a small example for a person suffering with acidity. How you will get relief from it? He will get relief from it whenever a base is added to him in the form of a chewing tablet or whatever it may be. But now, we will see some acid and base reactions. Now, children, now how we can perform this test in our lab? Very simple. How can we identify an acid is just being converted to salt? This we can see in the form of a small video. Now, children, here we are taking NaOH solution, it is a base. Now, what we are doing this? We are pouring into a small beaker. Now, let us see. I am pouring NaOH solution into a beaker. Now, I am adding a phenolphthalein indicator. Now, adding a small drop of indicator to the basic solution. Now, what happens whenever it is added to the base? Now, we are seeing pale yellow color, that means there is no indication for it. Now, I am taking NaOH solution, a base is being added here. Now, you can see pink color is appearing slowly in the beaker. Now, at this juncture neutralization reaction is begun, that means our base is turned to salt. Now, children, let us see what happens chemically here in the form of a small equation. In neutralization reaction, whenever HCl is added to NaOH, it turns to salt, it is sodium chloride. Now, let us see. Now, acid base neutralization reaction, a base is added to acid, we are getting salt along with the formation of water. NaOH is added with HCl and we are getting NaCl salt solution. Now, we have seen already in the video that whenever this salt solution is formed, that can be indicated with the color change with the help of methyl orange indicator. Now, let us see what neutralization reaction is actually. Now, in this neutralization reaction, we have seen that pink color disappears on adding HCl because NaOH is completely reacted with HCl. Now, here the effect of base is nullified with effect of acid. At this juncture, we will stop the reaction whenever the pink color appears in our beaker or conical flask. With that, we can conclude that a neutralization reaction, there will be a salt formation that can be indicated with the color change in a indicator. Now, we will see the reaction of acids with metal oxide. What metal oxides do we will find normally? A best example in our lab is copper oxide. What is the color of copper oxide? Yes, it is ash in color. Now, let us see experimental setup for it. Now, this is the color of copper oxide, its color is ash in color, it appears like cement at our home. Now, what happens when we add HCl to it? Whenever we add HCl, this copper oxide is turned to copper chloride with the formation of a salt. Now, this can be indicated with the color change, we are getting a pale green color in our test tube. Whenever this copper oxide is added to acid, it is turned to copper chloride. Here we are adding HCl, that is why it is turning into copper chloride. Suppose if we add nitric acid, its color will be changed to bluish in color because you will get copper nitrate. If you add H2SO4, you will see sky blue color in the test tube because it is converted to copper sulphate salt. Now, you see reaction of acids with metal oxides. What happens whenever a metal oxide is added to an acid? It turns to salt along with the formation of water, that we can see in the form of a equation. Now, here metal oxide is added to an acid, that is turned to salt and water. Now, here we are taking our example copper oxide and hydrochloric acid. Whenever hydrochloric acid is added to copper oxide, it is turned to copper chloride. Now, what happens whenever a base reacts with metal oxides? Same reactions, there will be a salt formation. Now, let us have a recap of today's topic, the chemical reactions between acids and bases and how they are changing with our laboratory indicators such as methyl orange indicator, phenolphthalein indicator, what is the litmus, how they are reacting with the litmus, red litmus test and blue litmus test, and also we have seen about olfactory indicators. Now, we have seen the experimental videos and simulations for reactions of acids with metals, reactions of bases with metals. Now, improve your learning. What would happen if a small amount of copper oxide is taken in a beaker and it is added with dilute HCl? Which gas usually is liberated when acid reacts with a metal? Now, illustrate with an example. Here you need to draw the diagram and also confirmation test for the gas which is evolved out, that is hydrogen gas. Dear children, so far we have learnt about the chemical reactions of acids and bases in this session, and in the next session we will see how salts are formed and what are the uses of important salts in our daily life. Thank you.